All right, now that we have talked about right triangles, we have done our Pythagorean theorem, we've talked about our special triangles, and we've even talked about how to find our geometric mean. Now it's time to get into the fun stuff, which is actually using our trigonometry to find the sides of right triangles if we needed to. So prior to today, if you were given a right triangle and you were only given one side, we would have to know some more information to this. And one thing would be helpful is if you knew what the angle measures were. Because if you knew it was a 45, 45, 90 triangle, then we would know that both of the legs had to be the same. And from our special triangles, we would know that our hypotenuse would then have to be 5 square roots of 2. If I was given a 30, 60, 90 triangle and my hypotenuse is 9, well, I would know that half of that would be my shortest side, which would be 9/2, and then my longest leg here would have to be 9/2 times the square root of 3, or 9 square roots of 3 over 2. Well, what do you do if you have a right triangle that only gives you one side and our angles that we have are not any of those special triangles that we've been working with? So then we're going to be using our right triangle trigonometry. So here's what you need to know about right triangle trig. First of all, we're working with right triangles, so you must have a 90-degree angle. And remember that your hypotenuse is always opposite of the 90-degree angles. Then we're going to have what we call our reference angles. So if I look at angle A as a reference angle, the two legs that are on this triangle have specific names to it. We have the opposite leg and we have the adjacent leg. Well, the opposite leg is the side that's opposite of angle A. So here we have the leg opposite of angle A. Then we have the hypotenuse, and the name of the hypotenuse never changes. The other leg, which is right here, is right next to angle A. And so we say that this is the leg adjacent to angle A. So you have your opposite side and you have your adjacent side, and then we have our hypotenuse. If you were to look at angle B, things are going to now change, because now the opposite side here would be AC. So the opposite here, here's my leg opposite to angle B. And then my length here of CB, now this would be my leg adjacent to angle B. So it matters what angle you are referring to. And so what we're going to be getting into this is using three sides: the hypotenuse, the opposite, and the adjacent. And so it matters which angle that we're working with. We will never reference that 90-degree angle because every triangle is going to have it. We're going to use the other two angles to help us out here. So we have to talk about our trigonometric ratio. This is where trigonometry starts. When we talk about sine, cosine, and tangent, this is its abbreviations. SIN is for sine, COS is for cosine, it's not cos or cos, and then TAN is for tangent. And so we're taking the sine of angle A, the cosine of angle A, and the tangent of angle A. The angle A that we have right here, this is the reference angle that we are referring to. And so I'm talking about angle A up here at the top. I'm not looking at angle C or angle B. Now these trig ratios hold true for any triangle that has a specific angle. That's what's going to happen, and we'll see that as we move forward. So talking about a ratio that occurs here. The sine of angle A, what we're going to be doing here is we're going to be taking the opposite side divided by the hypotenuse. So we're going to take the opposite and divide it by the hypotenuse. When you talk about the cosine, Okay, I probably should have done all of this here in blue so you can see the correlation between it. When I do cosine, it's not going to be opposite of hypotenuse, that's sine. We're going to take the adjacent side divided by the hypotenuse. So we're going to take adjacent and divide that by the hypotenuse. And then lastly, we have the tangent, which is going to take the opposite side over the adjacent side. Now you might be thinking, okay, how am I going to remember this? Well, there's a very easy three-word acronym that we're going to use to remember all of this right here. And it's called SOHCAHTOA. SOHCAHTOA. And all it's doing here is it's telling you that the sine of an angle is the opposite over the hypotenuse. CAH is telling you that the cosine of an angle is the adjacent side over the hypotenuse. TOA is going to tell us that the tangent of some angle is the opposite over the adjacent. So SOHCAHTOA, it's kind of weird, but it helps us with all of our ratios. So where this is going to help us now is being able to help us find sides and angles. But before we can do that, we have to be able to write out our trig ratios. So you'll notice here that I have 6 values. I've got the sine of n, cosine of n, tangent of n. All of these here are working off of angle n. Then I have the sine of angle L, the cosine of angle L, and I have the tangent of angle L, which is down here. These 6 values I have, now we can create 6 different ratios. So the sine of angle n, so I'm looking at angle n, the sine that we have here is opposite over hypotenuse. So I'm going to go to the opposite side, and then I'm going to go to the hypotenuse. So my sine of angle n is 15 over 17. That's its ratio. Next, I want to go ahead and take the cosine of angle n. Okay, cosine is adjacent over hypotenuse. Angle n, the adjacent side is 8. The hypotenuse is 17. So my ratio is 8 over 17. Lastly, you have the tangent, which is the opposite over the adjacent. So from my angle that I have, I'm going to go to the opposite side of 15, and the adjacent side is 8. And so I get 15 over 8. And that's all. You're just writing out those trig ratios. Now if I go to angle L, things are going to change. When I look at the sine, I'm going to go opposite of angle L, which is 8. The hypotenuse is 17. So I get 8 over 17. The cosine of angle L, now we're going to be taking the adjacent side. So angle L, the adjacent side is 15, the hypotenuse is 17. So I have 15 over 17. And then the last part here is working with your tangent. And our tangent is going to be our opposite over adjacent. So opposite is 8, adjacent is 15, so my ratio is 8/15. One more chance to just look at another example here. I'm going to go through this fairly quick. Angle K, if I start there, talking about the sine, I'm going to take opposite over hypotenuse, so I would end up with 12/13. Cosine of angle K, adjacent over hypotenuse, so 5/13. And tangent is opposite over adjacent, so I'd end up with 12/5. Angle J, if I were to look at that angle, doing the sine, opposite over hypotenuse, would be 5/13. Adjacent over hypotenuse for the cosine would be 12/13. And then the tangent would be opposite over adjacent to give me 5/12. So here are our trig ratios that we're working with. Now, what does this do for us? It's going to help us now find the missing sides of a right triangle. If it's not a special triangle like our 45-45-90 or our 30-60-90. Here I have a right triangle which has one leg of 12 and it's got an angle of 64 degrees, and it's got a missing leg of x. So I'm trying to solve this. I cannot use the Pythagorean theorem because I only have one side, and it's not a special triangle. So what we're going to be looking at here is we're going to look at this reference angle of 64 degrees. And I'm going to ask myself, okay, of the three sides, which side are they giving you? And so they are giving us here the adjacent side, which is going to be 12. So there's our adjacent side. Then I'm going to ask myself, okay, what angle do I want, or what side do I want to find? And x is over here opposite of our angle of 64 degrees. So then when I think of SOHCAHTOA, which of the three up here deals with adjacent and the opposite? So adjacent and opposite comes together with tangent. And so now I can set together my trig ratio. I have the tangent of 64 degrees is equal to the opposite side of x over the, opposite over the adjacent, so x over 12. What I'm now going to do is solve for x. Solving for x, I'm going to multiply both sides of my equation by 12. And here's where your calculator is now going to come into play, because we cannot answer this in our heads. We're going to have to use our calculator for it. So for here, how we're going to do this is, first of all, you want to make sure that your calculator is in degree mode. So I'll help you with that in class. If I look at my calculator here, I'm in radian mode, so I'm going to change that real quick. And if I'm going to find 12 times the tangent of 64, I'm going to just type in 12. And my tangent button is right here, right kind of straight above the 9. So 12 times the tangent of 64. Close the parenthesis, and then here's my answer, 24.6 approximately. And that's now my missing side of x. So I use tangent. I'm going to go through a couple another two examples here to help you with this whole idea. So here I have a reference angle of 39 degrees. They give me the opposite side, and I want to find the hypotenuse. So opposite hypotenuse, that tells me that I'm going to work with sine. So setting this up, I have the sine of 39 degrees is equal to the opposite, which is 60, over the hypotenuse, which is x. Solving for x, I have a problem with having x in my denominator, so I'm going to have to get rid of that by multiplying both sides by x. I now have x times the sine of 39 degrees is equal to 60. Solving for x, I'm going to now divide both sides of my equation by the sine of 39 degrees. The sine of 39 degrees, that is an actual number. You cannot just divide by 39. We cannot just divide by the sine. So I'm going to go to my calculator, and I'm going to take 60, and I'm going to divide it by the sine of 39 degrees. Hit enter, and I get 95.34. And that's all there is to it. All you're doing here is setting up that trig ratio, which we started with at the beginning of this lesson, and now we're just kind of solving and putting it into our calculator. Last example that I have here, I'm going to look at my reference angle here of 53 degrees, and they give me the hypotenuse, and I want to find the adjacent side. So we're going to talk about cosine this time. Now you have the cosine of 53 degrees is equal to the adjacent side over the hypotenuse. Solving for x, since x is divided by 27, we can go ahead and just multiply both sides of our equation by 27. And so x is going to be equal to 27 times the cosine of 53 degrees. So we go to our calculator, type it in, 27 times the cosine of 53 degrees, enter, and I get 16.25. Oops, I'm sorry. Let's fix this real quick. All right, 53. All right, so x we said was equal to 16.25. So as you're doing this, the important part is setting up your trig ratios, and that's all about the SOHCAHTOA. We'll practice putting this into your calculators when you get into class, and then we'll practice many of these problems since this is the first time you've done trigonometry. And that's it for today.